Whether you are managing a service station, a bookstore, or a coffee shop, you need to know how an increase or decrease in the price of your products will affect the quantity consumers are willing to buy. In the last chapter, we saw that cutting the price of a good increases the quantity demanded, and raising the price reduces the quantity demanded. But the critical question is how much? How much will quantity demanded change as a result of a price increase or decrease? Economists use the concept of elasticity to measure how one economic variable such as quantity demanded responds to the change in another economic variables such as the price. How much do gas prices matter to you? See if you can answer those questions by the end of the chapter. Elasticity is a measure of how much one economic variable responds to change in another economic variable. Let's start with the price elasticity of demand. Based on the definition of elasticity, price elasticity of demand is the responsiveness of the quantity demanded to a change in price, measured by dividing the percentage change in the quantity demanded of a product by the percentage change in the product's price. It reads as price elasticity of demand equal to percentage change in quantity demanded divided by percentage change in price. It's important to remember that price elasticity of demand is not the same as the slope of demand curve. So if the quantity demanded is very responsive to the changes in price, the percentage change in quantity demanded will be greater than the percentage change in price, and the price elasticity of demand will be greater than 1 in absolute value. In this case, we say demand is elastic. When quantity demanded is not very responsive to the price change. However, the percentage change in quantity demanded will be less than percentage change in the price, and the elasticity of demand will be less than 1 in absolute value. In this case, we say demand is inelastic. How do we translate this into mathematical language, or how do we calculate the percentage change? In this class, we're gonna learn two methods. One is the arc elasticity. We use midpoint method. We measure the elasticity over a portion of the curve. We use E sub p signifies the coefficient of the arc price elasticity. Q1 signifies the original quantity demanded. Q2 is the new quantity demanded. We use price 1 signifies the original price, and we use price 2 signifies the new price. Then the formula is EP equal to Q2 minus Q1 divided by the average of Q1 and Q2. Then use this result divided by the price 2 minus price 1 divided by the average of the price change, that is price 1 plus price 2 divided by 2. When do the calculations, we usually find out the Q1 plus Q2 divided by 2 and price 1 plus price 2 divided by 2 first, then do the divisions for each part. The other method is point elasticity. We will use point elasticity in the chapter of the demand estimation. Point elasticity is the elasticity measured at a given point of the demand or a supply curve. We use epsilon signifies the elasticity. Epsilon equal to the dq over dp times price 1 over q1. If the demand curve is linear, as what we've seen, in the last chapter is a straight line, then the point elasticity will be expressed as epsilon p equal to change in quantity over change in price times price 1 over Q1. We will not use point elasticity in this chapter, but we will use it in the chapter of demand estimation. So we will take a closer look at them. Suppose you own a service station and you are trying to decide whether to cut the price you are charging for a gallon of gas. You are currently at point A in this figure, selling 1,000 gallons per day at the price of 4 per gallon. How many more gallons you will sell by cutting the price to 370 depends on the price elasticity of demand for gasoline at your service station. Let's consider two possibilities. If demand 1 is the demand curve for gasoline at your station, your sales will increase to 1,200 gallons per day, from 1,000 to 1,200 after your cut price from 4 to 370 at point B. But if demand 2 is the demand curve for your gasoline, your sales will increase only to 1,050 gallons per day at point C. We might expect correctly, as we will see, that between these points, demand curve 1, D1, is more elastic than demand curve D2. But how do we confirm this? We need to calculate the price elasticity between the 2 points on the demand curve. Suppose you own a service station and you are currently able to sell 2,000 gallons of gasoline per day for 350 per gallon based on this demand curve. You are considering cutting the price to 330 to attract drivers who have been buying their gas at competing stations. Using the midpoint formula to calculate the price elasticity between these two prices. On each of the demand curves in the graph, here is one of the demand curve, demand 1. How do we do this? Okay, to use the midpoint method, we first calculate the average quantity and the average price for demand curve D1. That is, average quantity equal to the original quantity, that's 2,000, plus the new quantity, that is 2,500, divided by 2. Then we get the average quantity is 2,250. Then let's find out the average price. Average price is the original price 350 plus the new price 330 divided by 2. Then we get the average price 340. Now we calculate the percentage change in the quantity demanded and the percentage change in price for demand curve demand 1. Percentage change in quantity demanded equal to the new quantity. Remember, always new quantity minus the old one, the original one. The new one is 2,500 minus 2,000 divided by the average quantity. What we got from the last slide, 2,250 times 100 equal to 22.2%. Percentage change in price equal to the new price 330 minus original price 350 over 340. That's the average price we got from the last slide, times 100 equal to the minus 5.9%. In the end, we divide the percentage change in the quantity demanded, 22.2%, by the percentage change in price, minus 5.9%, to arrive at the price elasticity for the demand curve demand 1. That gives us minus 3.8. Remember, for price elasticity of demand, we only care about the absolute value of the price elasticity of demand. Okay, so here in this case, price elasticity of demand is minus 3.8. The absolute value of it is 3.8. So because the elasticity is greater than 1 in absolute value, that means the percentage change in quantity demanded is greater than the percentage change in the price. We say demand 1 is price elastic. Between these two prices, between the point A and B, the demand is elastic. Now let's calculate the price elasticity of demand for curve demand 2 between these two prices. Using the same method, we first solve for percentage change in the quantity demanded. It gives us 4.9%. Percentage change in price, which is minus 5.9%. Then we divide the percentage change in quantity by percentage change in the price. We get a price elasticity of demand is minus 0.8. The absolute value of it is 0.8. It's less than 1. So we say the demand 2 is price inelastic. Here's something we need to know about elasticity. When demand curves intersect, the flatter curve is more elastic, as you've seen in the last slide when we compared demand 2 and demand 1. Remember that elasticity is not the same thing as slope. Where slope is calculated using changes in quantity and price, elasticity is calculated using percentage changes. But it's true that if two demand curves intersect, the one with the smaller slope, in absolute value, the flatter demand curve is more elastic, and the one with larger slope, usually we say the curve is more steep. In absolute value, the steeper demand curve is less elastic. Although they do not occur frequently, we should be aware of the extreme or polar cases of the price elasticity. If the demand curve is a vertical line, it's perfectly inelastic. In this case, the quantity demanded is completely unresponsive to price, and the price elasticity of demand equals 0. No matter how much price may increase or decrease, the quantity demanded remains the same. The product such as the drug insulin for the diabetes patient is an example. If the demand curve is a horizontal line, it is perfectly elastic. In this case, the quantity demanded is infinitely responsive to the price. The price elasticity of demand equals infinity once again. The perfectly elastic demand curve are very, very rare, but we will talk about this, or we say this piece of the knowledge will be applied to one of our chapter later. This slide and the following two slides summarize the different price elasticity of demand. When the absolute value, remember for price elasticity of demand, we check the absolute value of the price elasticity is greater than 1, we say the demand is elastic, which shows the percentage change in price causes greater percentage change in quantity demanded. When the absolute value of the price elasticity is less than 1, then the demand is inelastic. When the absolute value of price elasticity equals to 1, the demand is unit elastic. When the absolute value of price elasticity equals infinite, we say the demand is perfectly elastic. Say the demand curve is a horizontal line. When the demand curve is when the absolute value of the price elasticity equals to 0, the demand curve is a vertical line. We say the demand is perfectly inelastic, does not respond to the price change at all. We have seen that the demand for some products may be elastic, where the demand for other products may be inelastic. In the following several slides, we examine why price elasticity differ among products. The key determinants of the price elasticity of demand are as follows. The availability of substitutes is the most important determinant of the price elasticity of demand, because how consumers react to a change in the price of a product depends on what alternatives they have. In general, if a product has more substitutes available, it will have a more elastic demand. If a product has fewer substitutes available, it will have less elastic demand because consumers they do not have many choices. Passage of time. It usually takes consumers some time to adjust their buying habits when prices change. For example, if price of gasoline increases, it takes a while for consumers to decide to begin taking public transportations, to buy more fuel-efficient cars, or to find a new jobs closer to where they live. The more time that passes, the more elastic the demand for product becomes. Next one is luxuries versus necessities. Goods that are luxuries usually have more elastic demand curves than goods that are necessities. The demand curve for luxury is more elastic than the demand curve for a necessity. For example, demand for bread is inelastic because bread is a necessity. The next determinant is the definition of market. In a narrowly defined market, consumers have more substitutes available. The more narrowly we define market, the more elastic demand will be. For example, if you own a service station and raise the price you charge for gasoline, many of your customers will switch to buying from a competitor. So the demand for gasoline at one particular station is likely to be elastic. People respond to your price change. You raise the price, they go to other gas stations. But the demand for gasoline as a product, on the other hand, is inelastic because consumers have very few alternatives. Share of a good in consumers' budget. Goods that take only a small fraction of consumers' budget tend to have less elastic demand than goods that takes a large fraction. In general, the demand for a good will be more elastic the larger the share of the good in average consumer's budget. For example, table salt. Most people spend only a very little share of their income on salt. As a result, even a doubling of the price of the salt would not change the quantity of the salt they would buy. This table shows some estimated real-world price elasticity of demand. It's very important for the business managers to know the price elasticity of their own products. Why we say it's very important for managers to know the price elasticity of their products? Because it allows the firm to calculate how changes in price will affect its total revenue. Total revenue is the total amount of funds received by a seller of a good or services, calculated by multiplying price per unit by the number of units sold. To understand the relationship between the price elasticity and the total revenue, let's consider this figure. At point A, the price is $4 per gallon and 1,000 gallons are sold, and the total revenue received by the service station equals 4 times 1,000, or $4,000. At point B, cutting the price from $4 to $3.70 increases the quantity demanded from 1,000 to the 1,050 gallons, but the fall in price more than offsets the increase in quantity. As a result, revenues falls. The new revenue is $370 times 1,050. It gives us 3,885. It's less than the 4,000. So our conclusion is when demand is inelastic, a cut in price will decrease total revenue. On this slide, this figure shows the demand that is elastic between the point A and B. In this case, cutting the price from $4 to $3.70 increases total revenue because elastic demand means customers respond greatly to the price change. Lower prices will attract more people to buy and buy more of the products. So at point A, when price is $4 per gallon, the total revenue is $4,000. When the price is reduced to $3.70, total revenue is $4,440. We got that from $3.70 times 1,200. So in this case, increase in quantity demanded is large enough to offset the fall in the price, so total revenue increases. Let's summarize the relationship between the price elasticity and total revenue. If demand is elastic, then increase in price reduces revenue. If demand is elastic, then a decrease in price will increase total revenue. If the demand is inelastic, increase in price increases revenue. If demand is inelastic, a decrease in price will reduce revenue. If the demand is uninelastic, then increase in price does not affect revenue. Same, the decrease in price does not affect revenue either. Okay. So for managers, if you know the demand for your products, the price elasticity of demand for your products is elastic, then in order to increase the revenue, you should cut the price instead of raise it. If the price elasticity of demand for your products is inelastic, then in order to increase your total revenue, you should increase your price instead of reducing it. We just learned for the different demand curves, right? For the different demand curves and when they intersect on the same graph, the flatter one is more elastic than the steeper one. But for the same demand curve, when we move down the demand curve, the price elasticity declines. That means along the same demand curve, price elasticity of demand is not same. This slide showed us how the relationship between the price elasticity and the total revenue along the same demand curve as illustrated. Remember, we learned that price elasticity of demand is not the slope of the demand curve. Slope of the demand curve is the same. But among most demand curves, elasticity is not a constant at every point. For example, a straight or we say linear demand curve for gasoline is shown in this graph. The data from the table are plotted in the graphs. The panel A shows that as we move down the demand curve for gasoline, the price elasticity of demand declines. In other words, at higher prices, demand is elastic. At lower prices, demand is inelastic. Panel B shows that as the quantity of the gasoline purchased from 0, revenue will increase until it reaches a maximum of $32 when 8 gallons are purchased. As purchases increase beyond 8 gallons, revenues falls because during this part, when the purchase increase 8 gallons, for this demand curve, when price decrease and the total revenue decrease because for this part of demand curve, elasticity is inelastic. As we learned, when the demand curve is inelastic, then the total you cut in the price, your total revenue will decrease. Elasticity is an important concept in economics because it allows us to quantify the responsiveness of one economic variable to changes in another economic variables. In addition to price elasticity, two other demand elasticities are also important: cross elasticity of demand and income elasticity of demand. Cross price elasticity of demand, usually we call it cross elasticity of demand. It's a percentage change in quantity demanded of one good divided by percentage change in the price of another good. Suppose you need to predict the effect of a decrease in the price of a Pepsi Cola on the quantity of demand for Coca-Cola. Holding other factors constant, you can do this by calculating the cross price elasticity of demand, which is the percentage change in quantity demanded of the Coca-Cola demanded divided by the percentage change in the price of the Pepsi Cola. If the products are substitutes, then cross elasticity of demand will be positive. Reversely, if the cross elasticity is negative, then the two products are complements. If the elasticity is 0, means two products are not related. If the cross elasticity is greater than 1 in absolute value, then which means two products are close substitutes or complements. Income elasticity of demand mirrors the responsiveness of quantity demanded to change in income, measured by the percentage change in quantity demanded divided by the percentage change in income. As we learned in the last chapter that if quantity demanded of a good increases as income increases, then the good is a normal good. Normal goods are often further subdivided into luxuries and necessities. A good is normal and luxury if income elasticity of income is positive and greater than 1. Is normal and a necessity if the elasticity is positive but less than 1. A good is inferior good if the elasticity is negative. So for price elasticity of demand, we ignore the sum, the minus sum, or always take the absolute value of the price elasticity of demand. But for cross elasticity of demand and income elasticity of demand, we need to keep the sum. If that's positive or the minus, because the sums are important here for those two kind of the elasticities. The concept of price elasticity and income elasticity can help us understand many economic issues. For example, some people are concerned that family farm is becoming an endangered species in United States. In 1950, U.S. farmers produced a billion bushels of wheat at a price of $18.56 per bushel. Over the next 60 years, rapid increase in farm productivity caused a large shift to the right in the supply curve for the wheat. The income elasticity of demand for wheat is very, very low. So the demand for wheat increased relatively little over this period. Because the demand for wheat is also price inelastic, the large shift in the that means the demand curve is steep, okay? So the large shift in the supply curve and the small shift in the demand curve resulted a sharp decline in the price of the wheat from 18.56 per bushel in 1950 to 5.70 per bushel in 2011. The result is the paradox of American farming. Ever more abundant and cheaper food supplied by fewer and fewer farms. We use the concept of elasticity to measure responsiveness of firms to a change in price, just as we use it to measure consumers' responsiveness. Just as with the price elasticity of demand, we calculate the price elasticity of supply by using percentage changes. Price elasticity of supply measures the responsiveness of the quantity supplied to a change in price, measured by dividing percentage change in quantity supplied to a product by the percent change in the product's price. Whether the supply is elastic or inelastic depends on the ability and willingness of firms to alter the quantity they produce as price increases. It's different from the determinants of the price elasticity of demand. For the price elasticity of supply, the main determinants are times. Often, firms have difficulty increasing quantity of the product they supply during any short period of time. So the supply tend to be more inelastic during the short time and tend to be more elastic during a longer period of time. Next three slides are the summaries of price elasticity of supply. If supply is elastic, then the value of price elasticity is greater than 1. So when the price elasticity of supply we calculated is less than 1, then it means supply is inelastic. You can also tell if you put two supply curves on the same graph and they intersect, and the flatter supply curve is more elastic and the steeper one is less elastic. When the value of the price elasticity is equal to 1, that means the supply is unit elastic. If the price elasticity we calculated is equal to the infinity, that means the price is perfectly elastic. The supply curve is a horizontal line. Perfectly supply curve is one extreme. The other extreme is when the supply is 0. The price elasticity of supply is 0 when the supply curve is a vertical line. Okay, it's a vertical line. That means the supply does not respond to the price change at all. Now we can put demand and supply together to analyze how to use price elasticity of supply to predict changes in price. This figure illustrates the important point that when demand increases, the demand curve moves to the right. The amount by which price increases depends on the price elasticity of supply. For example, here, the figure shows demand typical, represents the typical demand for parking spaces on a summer weekend at a resort. Demand July 4th represents the demand on the 4th of July. Because supply is inelastic, so the shift in equilibrium from point A to point B result in a large increase in price from the $2 per hour to $4 per hour, but only a small increase in the quantity spaces supplied from 1,200 to 1,400. Okay, we conclude when the supply is inelastic, increase in demand can only bring up the price, and the quantity supplied will increase only a little bit. But in the case when the supply is elastic, as a result, the change in equilibrium from point A to point B results in a smaller increase in price and a large increase in quantity supplied. So when supply is elastic, so suppliers, they will respond to the demand, the demand change here. When there is a big increase in the demand, when the supply is elastic, can only cause the price change a little bit, but will increase the quantity supplied. Increase from 2 per hour to 50 is sufficient to increase the quantity of parking supplied from 1200 to 2100. Okay, that's all what we need to learn about elasticity for this class. If you have any questions, please let me know by sending me email. Please do not use the Moodle message, or join me during the online office hour on Thursday night at 7 p.m.